Okay, next is question number 16 from May 2023 Physics Unit 1 paper. So here in question 16 it says a small spherical air bubble moves upwards in a glass of water. Fine, it is what? Small spherical air bubble. Okay, the drag force on the bubble can be calculated using the Stokes law. Okay, fine. State the condition needed for Stokes law to apply to the bubble. Okay, there's a lot of conditions we know, right? For Stokes law, like the particle, the object should be it should be spherical, it should be what, of small radius, right? And it will be slowly moving. The flow of fluid around it should be laminar. Lots of what, a condition, right? So since the question has already said it is small spherical, so let's ignore these two. We will consider the rest two, which are the flow of fluid around the bubble is laminar, should be laminar. This is one. Or you can write here only one you have to write, or you can write here uh, the bubble is moving slowly. Both are interrelated to each other, because if the bubble is moving slowly, then the flow of fluid around it will be laminar, definitely. So you can write either of them. Okay, so I'm writing here the flow of fluid around the bubble, air bubble, should be what? Should be what? Laminar. Okay, that's it. Fine. Okay, next is part B. In part B, the question says the bubble moves upwards at a constant velocity. Okay, since it's moving with constant velocity, that means it has reached its terminal velocity, isn't it? Okay, the volume of the bubble is 5.3 times 10 inverse 11 meter cube. So part 1, it's asking to show that the upthrust on the bubble is about 5 times 10 to the 10 inverse 7 Newton. The density of water, it's given 998 kg per meter cube. Okay, so we need to find out the upthrust. Okay, upthrust is what? V times rho times g, right? So F upthrust, it is what? V rho g, isn't it? So volume of bubble, it's given as 5.3 times 10 inverse 11, right? And then density is given as what? 998 kg per meter cube times what? Times g, 9.81. Okay, so what would be the value? 5.3 times 10 inverse 11 times 998 times 9.81. So that would give you 5.1889014 times 10 inverse 7 what? Newton. It's a force, so it should be Newton. So we can write it as what? 5 times 10 inverse 7 Newton. That's it. Showed. Fine. So we got the upthrust. Okay. Fine. Next is part B2. Okay. In part B2, the question says the bubble moves upwards at a constant velocity of 0.035 meter per second. Deduce whether Stokes law applies to the bubble. Okay. You may ignore the weight of the bubble, viscosity of water. This is 9.5 times 10 inverse 4 Pascal second. Okay, that's the unit for viscosity. Okay, so we have to ignore the weight of the bubble. Okay, that means when, since we are ignoring the weight, that means uh, the upthrust is equal to the drag force, right? The bubble, it has upthrust in the upward direction, it has drag force in the downward direction, right? So this F drag will be equal to the upthrust. So to find out the upthrust. Okay, we already got the upthrust in the previous uh, part. We know the exact value, no problem. So we got the upthrust. Now let's figure out the viscosity, because the given viscosity is 9.5 times 10 inverse 4 Pascal second, right? Or yeah, so we can do one thing. We know that viscous drag, right? This is what 6 F drag, it is equals to what 6 pi r eta v. Okay, so 6 pi r eta v. In that case, you can do you can approach this answer in two ways. Either you find out the terminal velocity v, or you find out the viscosity and compare with the given one. Okay, so let us consider the terminal velocity in that case. So 6 pi r eta v terminal, it is equals to what? It is equals to the upthrust, which is 5.188 given 5.188 something times 10 inverse 7 Newton. Okay, so from there we will find out the terminal velocity. So terminal velocity, and then we will compare it with the given answer. So do we know the radius? The volume of the bubble is given. Okay, so no problem, we will figure it out because the bubble is definitely spherical, isn't it? Okay, 10 inverse 7, so that would be 6 pi radius we need to figure out. So 6 pi times eta is 9.5 times 10 inverse 4 times the radius. Okay, let's figure out the radius. We know the volume, right? The volume is given, we don't it's given. So we know that volume of a sphere, it is what 4 over 3 pi r cube, it is equals to what? It is given as 5.3 times 10 inverse 11. Okay, so 5.3 times 10 inverse 11, that much meter cube. Okay, so from there just find out the radius. What you will get, the radius is 5.3 times 10 inverse 11 times 3, yeah, times 3, and then divide 4 times 3.1416. Okay, and then you have to cube root the whole value. Okay, so you will get the radius is basically 2.3302111895 meter. Okay, so this is the radius. So the radius we got 2.33 times 10 inverse 4. Okay, I missed it out. It should be 10 inverse 4, that much meter. So times 10 inverse 4 meter. Now calculate what would be the value. So in the numerator, the exact value is 5.1889014 times 10 inverse 7 divide 6 pi. So 6 times 3.1416 times 9.5 times 10 inverse 4. Okay, times 2.3302111895. Okay, this is saved in my calculator, so this is the answer. Okay, answer. Okay, so in the numerator we have 5.188 something times 10 inverse 7. In the denominator we have 6 pi times 9.5 times 10 inverse 4 times the answer. Basically answer is the radius of the sphere, of the bubble sphere. Okay, so the terminal velocity you will get here, it is basically v terminal. Okay, so we got the v terminal, it is equals to 0.124 0.124 124 3524 3524 252. Okay, 252 meter per second, which is what? Not equal to the given one. The given one is how much? The given one is 0.035 meter per second. 0.035 𝗔-𝗟𝗖𝗖 meter per second. So that means Stokes law is not applicable here. Okay, so we can say that hence Stokes law. Okay, hence Stokes law is not applicable. That's it. Okay, so that's what part 2 of question number 15B has asked. 16B has asked for, and that's the end of question number 16 from May 2023 Physics Unit 1 paper. Fine.